You know, it's funny. Some of the most chaotic things you can think of, the stock market, how populations grow, they actually follow some pretty predictable mathematical rules. Today, we're going to pull back the curtain on the simple patterns hiding in plain sight, and we'll use them to solve a math riddle that has stumped some of the greatest minds for centuries. So let's just dive right in. We're not going to start with some dry definition. Instead, let's start with a puzzle. A puzzle that has seriously confused brilliant people for a long, long time, all about adding up an infinite string of numbers. Okay, take a good look at this. It's called Grandi's series. The question is, what does it all add up to? I mean, we're just adding and subtracting 1 over and over and over, forever. It seems like it should be the easiest math problem in the world, right? Well, this is exactly where things get weird. What's so wild is that the answer seems to completely depend on how you look at it. So, for example, if you group the numbers into pairs right from the start, you get a bunch of 1 minus 1s. And what's that? It's just 0 plus 0 plus 0, which is obviously 0. But what if you just shift your view a little? Leave that first one all by itself. Now all the other pairs add up to 0 and you're left with 1. So, which one is it? Is it 0 or is it 1?
Get this. For hundreds of years, some really smart mathematicians, including the guy it's named after, Grandi, argued that the real answer is 1/2. How on earth can you add and subtract whole numbers and end up with a fraction? To figure that out, we need to build ourselves a toolkit.
To solve that riddle, we first have to understand the two main ways that numbers can follow a pattern. Think of these as the basic rules of the road for any sequence of numbers. First up, we've got the arithmetic progression, or AP for short. This is your steady, predictable, straight line kind of growth. It's like taking perfectly even steps, one right after the other. Or maybe you save exactly $10 every single week. The amount you're adding is always the same. That's an arithmetic progression.
And then we have its wilder cousin, the geometric progression, or GP. Now instead of adding, we're multiplying. And this is where things can get, well, explosive. Think about a video going viral. The number of views doesn't just go up, it doubles every hour. Or a snowball rolling downhill, getting bigger and bigger, faster and faster. That's geometric.
So here's the whole thing in a nutshell. With an AP, you're always adding a fixed number, which we call the common difference. With a GP, you're always multiplying by a fixed number, the common ratio. And that one tiny change, adding versus multiplying, is the difference between steady, linear growth and explosive exponential growth. Okay, so now we know the different kinds of patterns. Let's get the tools that let us actually predict and control them. These are the formulas that really unlock their secrets.
These two little formulas here are incredibly powerful. With them, you can find any number in a sequence, the 10th one, the 50th, the millionth one, without having to write the whole thing out. For an AP, all you need to know is the first number, A, and that common difference, D. And for a GP, you just need that first number, A, and the common ratio, R.
Let's think about a taxi fare, for example. It's a perfect real-world AP. You've got that starting fee, that's your A, and then a fixed cost for every extra mile you go, that's your D. The price just ticks up in those steady, predictable arithmetic steps.
Now for a GP, just think about your family tree. You have 2 parents. They each have 2 parents, so that's 4 grandparents. And they each had 2 parents, giving you 8 great-grandparents. The number doubles with every single generation. It just shows you how fast a geometric progression can completely explode.
So these patterns aren't just, abstract ideas from math class. They are literally everywhere. They describe how our world works, from your bank account to biology.
Arithmetic progressions are all about things that change steadily. Think simple interest on a loan, or how a car's value might drop by the same amount each year. But geometric progressions, that's where you see things that accelerate. It's the magic of compound interest, the rapid spread of a virus, or even the decay of a radioactive element.
And this is where we really see the pattern inside the chaos. On the left, that's the actual unpredictable path of the stock market. On the right, that's a mathematical simulation called Brownian motion. It looks just as random, doesn't it? But this model, which people use to try and predict financial markets, is built on the core ideas of geometric progression. It's using the logic of accelerating patterns to try and make sense of what looks like pure chaos. Okay, toolkit assembled. We know the difference between arithmetic and geometric patterns. Now we can finally go back and solve that impossible riddle from the beginning. So let's look at our series again. 1, then -1, then 1, then -1. To get from one number to the next, what are you doing? You're multiplying by -1 every single time. And that means this isn't just some random list of numbers. It is a perfect geometric progression. The first term is 1, and the common ratio, our r, is -1.
And this brings us to the most important rule about adding up an infinite geometric series. The truth is, sometimes you just can't. In math, there's a word for this. We say the series diverges. It basically means it never settles down on one single final number.
So here's the key. You can only find the sum of an infinite geometric series if it converges, if it actually narrows down to a specific number. And that only happens when the absolute value of that common ratio r is less than 1. So for our riddle, the ratio r is -1. The absolute value of -1 is just 1. And 1 is not less than 1. So the series diverges. It just bounces back and forth between two values forever, never landing on a final answer.
And there it is. The mystery is solved. The answers of 0, 1, and even 1/2, they're not real. They're like mathematical illusions you get when you try to force a conclusion, when you apply formulas and rules to a series that, by its very nature, refuses to be pinned down.
We've seen the two big, fundamental patterns that sequences follow. But that leaves us with one final, kind of mind-bending question. What happens if you try to combine them?
Well, you get something called an arithmetico-geometric sequence. Just look at this example. The top of the fraction, the numerator, is growing steadily 0, 1, 2, 3. That's our arithmetic pattern. But the bottom, the denominator, is exploding exponentially. 1, 2, 4, 8. That's our geometric pattern. These hybrid patterns show up in more advanced stuff like probability theory. And they're a great reminder that even when you think you've figured out the basic rules, there's always a new, more complex layer of order just waiting to be discovered.